In this video, we'll be covering all about the variables and assignment, that is how the variables are used and how they are assigned with their respective objects. So first of all, I'll be telling you about the variables. Now talking about the variables, variables are the placeholder for your values. Variables are used to avoid the recomputing of your values. For example, if you want to use a particular value again and again, it's better to store that value in a variable instead of writing that value again and again. Suppose you have to type Python is an awesome language 100 times in your code. Here it's better to store a string into the variable and use that variable. Variable gives the name to the value that helps the reader to understand the code. For example, if you want to store the name of the person, then use name as the variable so that whenever you read your program or someone else reads it, he or she is able to understand what kind of the data is stored in their variable only by reading it. Also, a variable is a value that can change depending on the condition or an information passed to it in a program. So this was just the introduction part of your variable. Next, we'll talk about the rules of the variable. That is, the very first rule is the case sensitive. Variables are case sensitive. That is, the name with your small n and the name with your capital N. Both are two different variables. Next rule is the reserved word. Reserved word cannot be used as the variable. Example, true with a T capital cannot be used as a variable name as because it is actually a boolean value in Python. So if you are using true with the small tree, it will be considered as the variable over here, but with the capital T, it is considered as your boolean value. Next, there are some legal and illegal variables which states that the variable name must start with an underscore or letter. It cannot start with an sign, which will not be a valid entity. Now, variable name started with the letter can be followed by any digit or your underscore, but the variable name should not start with the integer value over here. So this was all about the variables and the variable declaration and how the rules are assigned into their names with respect to their names. Next, we'll talk about the dynamic typing. Now, the fundamental idea behind the conciseness and flexibility of the Python language is dynamic typing and the polymorphism it applies. See, the dynamic typing means that there is no need to declare the variables before using them. In Python, the types are determined at runtime, not in responses to the declaration in your code. For example, a is equals to 3 works in Python even if you have never told Python to use the name a as the variable, or that is, a should stand for an integer type of object or not. In Python, these all pans out in a very natural way. We have the very first one is your variable creation. Now, a variable is created when your code first assigns it a value. Future assignment changes the value of your already created name. Let's have a look on the shell for that. We have a is equals to 0 over here. That is a I have declared as my 3 and I'm retrieving my a in the next line. You can look at the output. It is giving me the 3 value. Now again a is being used as the 6. Now the a value I'm retrieving is your 6 value over here. So it is just taking the entries which are very recent. Next one is the variable type. That is, a variable never has any type information associated with it. The notion of your type lives with the object, not with the names. So over here, when I was declaring my a, you can look over here, that is the a is my 3. But suppose if I take another, that is my b should be the string. So in order to define a string, we just use the inverted commas. Now you can look over here, if I'm retrieving my b, it is actually storing me a string. So no matter what you have told to the interpreter that to store the digit or your number or your alphabet, it just stores it automatically and the type of the object lives with the object itself. Next we have is your variable use, that is when a variable appears in an expression, it is immediately replaced with the object that is currently refers to. So the all variable must be assigned before they can be used. Referencing unassigned variable results in your array. That is over here, I haven't defined any C value, but when I'm retrieving my C, it will give me a name error over here as because my C is not defined. So variables must be used, that is variables should be assigned before using them. In brief, variables are created when assigned and can refer any type of the object and must be assigned before they are referenced to. So this was all about the dynamic typing. Next we'll talk about the assignments over here. Moving ahead, we have the assignment. Now let's have a look over the assignment of the variables. That is, first of all, the variables used. The variables are the entries in the system table with spaces for the link to your object. Variable always links to the object and never to other variables. But these larger objects may link to your other objects. Now this concept will become more clear when you will study the various data types of the object that Python has. Next is the object. Now talking about the object are the pieces of the allocated memory with enough spaces to represent the values for which they are stand. Next is the references. That is the link from the variables to the object is called your references. That is the reference is kind of an association implemented as the point of a memory. So we have variable, we have object, and the link towards your variable and the object is referenced by a reference over here. Let's have a look on the example. That is assigning a name to an object. Here I'm taking the 3 steps to perform this assignment of the name to your object. The very first is your object. Suppose we want to assign a variable a to value 3. Now the very first step is creating the object to represent the 3 value. That is over here the object is created, then creates the variable a if it does not exist. If it does not exist, then only the variable will be created, otherwise the link from the previous the already used variable will be referenced over here. And the third step is the link, that is link the variable a to the new object 3. So the very last step is your referencing, that is linking the object and the variable you have defined over here. So the net results will be a structure inside Python that resembles the figure shown over here. As shown here, the variables and the objects are stored in the different parts of your memory and are associated by the link we have referred over here. So this was all about the assignment, how the variables and the objects get assigned over here. Next we'll talk about the type lives with the object or not with your variables. Here I'm assigning a variable multiple times. The very first is your a is equals to 5, which is an integer. Then a is equals to su, which is a is your string, and a is 3.72. Now it's the floating point number over here. So in this example, we have simply changed a to the referencing different object because the variable have no type. We haven't actually changed the type of the variable a. We have simply made the variable reference a different type of your objects. So objects on the other hand know what type they are. Even the object contains a header file that tags the object with its type. For example, the integer object 5 here will contain the value 5 plus a designator and tells the Python that the object is an integer. The other header file, that is the reference counter. To understand this, let's first get what is the garbage collection. Objects are garbage collected, that is, whenever a name is assigned to a new object, the space held by the prior objects is reclaimed if it is not referenced by any other name or your objects. So this automatic reclamation of the object space is known as your garbage collection. The object space is automatically thrown back into the free space pool to be reused for the future objects. Now, internally, Python accomplishes this by keeping a counter in each object that keeps track of the number of the references currently pointing to that object. So, as soon as this counter drops to a zero, the pointer memory space is automatically reclaimed. Now, in this example, each time A is assigned to the new object, the prior object reference counter drops to a zero, causing it to be reclaimed over here. So with this, the Python will clean up unused space for you as your program runs. In practice, this eliminates a substantial amount of your bookkeeping code required in your lower level language such as your C and C++. So this was all about the assignment. Next we'll talk about the shared references. Talking about the shared references, the very first example I've taken over here, that is your A is equals to 3. Here A is assigned to their value 3. So the very first thing will be the making of the object over here, and then the variable, and then the link to the object and your variable. And in the second statement, we are creating the variable B. Here we are using the variable A, not assigning it to be replaced with the object it is referencing, that is your 3, and B is made to the reference that object. So the net result is that the variable A and B wind up referencing the same object. Now this scenario in Python with multiple name referencing the same object is called your shared references. Now let's take another example. Let's add one more statement over here, that is your A is equals to 3. So the very first step is your object creation, then the variable, and then the link. So up till now I've just covered the previous example. Now let's add one more statement, that is your A is equals to AB. As with all Python assignment, this statement simply makes a new object to represent the string value over here, and sets A to reference this new object over here. So it doesn't, however, changes the value of your B. B is still referencing to the original object, that is your integer 3. So this is how we can explain the shared references in your Python. Next we'll talk about the hands-on over here. We have many of your programs to run to look over here. That is, let's see. The very first program is of your swapping concept. That is, your swapping is in the very first line, I've just taken A as your 10, declared A with my 10 value, B with my 20 value, and simply printed my A and B. Now in the swapping concept, what I have done is my A I have taken as the A, temp I have taken as my A. So the temp is actually storing my 10 value over here because it is linked to my A. And then the next I have declared, that is A should be my B. So now my A is storing the 20 value as because it is linked to my B value. And again I am linking, that is B should be stored with their related with your 10. So earlier the temp was having 10 value, now the B will have your 10 value over here. So with this you can say the temp variable, I have just swapped all of the values, the both of the values I have swapped over here. And in the next slide, I'm simply printing, that is print A and B. So you can look on the output over here. You can run it by your F5, or either you can press your that is, look over here on the output. The earlier it was 1020 and later on it is your 2010. That is, your swapping of both of the numbers has been done. So over here I'm not using the interactive shell. It is actually a file created in your Python. Now this file can be run by simply using your F5. So Python code is much easy as compared to your other languages. Let's see this power of your Python by minimizing the code. Let's look on the another program of swapping where whole swapping concept is minimized in few lines of your code in your Python. Have a look over here. We have A is equals to 10, B is equals to 20, and I have simply printed A and B. Now, the swapping of the both of the number I have done in my single line. That is A I have linked with my B and B I have linked with my A. So that is A is made and I'm linking my B with my A over here. So what it does is that it stores the value of your A in your B and value of your B in your A. So this is how the swapping concept takes place by minimizing the code. In a single line, I have just made the code more easier. Let's have a look at the program. That is your output of the program. You can have a look. The swapping of both of the numbers has been done. So earlier it was 10, 20. Later on it is your 20 and 10. Now this was just the swapping concept. Let's next have a look on the variable program we have over here. That is in the variable, the very first line is your numbers, that is declaring your numbers. Number 1 is equals to 10, number 2 is equals to 20, and simply I'm using them for my adding purpose. So in this, I'm simply adding both of the numbers and storing in my sum. In the next, I've simply subtracted both of the numbers and stored in a diff. I'm trying to retrieve the diff on my output. And with the next line, I have declared a third number, that is number 3 is your 5, and the sum which I got from my number 1 and number 2, adding both of the numbers, I have multiplied that sum with your number 3 and simply saved in my mind. So this is how you use your variable and declare with your variable and perform various kind of your operations with them. Let's run it and see the output as well as. That is your sum is your 30, differences is minus 10, multiplication is 150. And in the last line I've simply printed, I have 2 kinds, so it is giving me the output on the screen.